Welcome. Today we'll explore an interesting property of trigonometric functions by looking at successive derivatives. Our question is, given y equals a cosine x plus b sine x, what happens when we take derivatives 4 times in a row? Let's start with our original function. Y equals a cosine x plus b sine x. We'll call this equation 1. Now let's take derivatives step by step. For the first derivative, remember that the derivative of cosine x is negative sine x, and the derivative of sine x is cosine x. So y sub 1 equals negative a sine x plus b cosine x. Taking the derivative again, we get y sub 2 equals negative a cosine x minus b sine x. Notice how the signs are changing as we differentiate. For the third derivative, we get y sub 3 equals a sine x minus b cosine x. Finally, for the fourth derivative, we get y sub 4 equals a cosine x plus b sine x. Look carefully at this result. Does it look familiar? It's exactly the same as our original function. Let's visualize this pattern. We can see that the derivatives form a cycle, starting with cosine x and sine x, then negative sine x and cosine x, then negative cosine x, and negative sine x, then sine x and negative cosine x, and finally back to cosine x and sine x. Therefore, we can conclude that y sub 4 minus y equals 0, proving that the fourth derivative equals the original function. This is a fascinating property of sine and cosine functions that demonstrates their cyclic nature in calculus.